Cool. Welcome, everybody. We're going to get started with a workhorse discussion. This is mostly the package team with an interest towards answering questions about our future direction for the container registry. Nick Thomas is on the phone. Yeah, we're on the phone. Nick Thomas is on the call, and hopefully he can give us a little bit of a hand with that. And it sounds like you might have some questions with around the container registry as it is right now, Nick, and we'll be doing our best to answer those. So my first question is, I think from the document is really, what's the design intent for Workhorse? I feel like you answered that down below, Nick, but it seemed like your answer was, it was generally just to support Rails in terms of requests that are long running or something like that. Is that correct?
Yeah, I mean, the basic philosophy is that Rails tells Workhorse what to do. I don't think there's really anything in Workhorse that is not directed in some way by Rails. So originally the idea was that it would take over expensive and long-running requests, because in Unicorn, the RAM megabyte seconds involved in servicing a request are huge. So instead, Unicorn returns to Workhorse a very simple response saying, go and do this Gitly RPC call, for instance. Originally, it was run this Git command for me and pipe the output of that back to the user. That's the idea in Workhorse, really. Rails tells it to do something. Workhorse takes every request that goes through to Rails. It does very little with most of the incoming requests. It just passes them straight on to Rails. Rails then interprets that, gives back a response, and in some cases, that response makes Workhorse do something special, like call out to Gitly. Other times, depending on what's coming back, the response is just passed back to the clients or notified. It's a slightly special with us.
Yeah, Nick, but in case of user uploads, it behaves a bit differently. He hijacked the requests and changed the behaviors for Rails, so it requires Rails to do special things on behalf of workers. And I think that here we are in the middle ground, because part of the the register thing is dealing with large blob of information. So we could be in a kind of a middle ground between the smart reverse proxy thing and doing something more specialized.
As I understand the file upload, and I know my understanding of it isn't quite as good as yours, but in that case, we still talk to Rails and essentially say, there's somebody here who wants to upload a large file. Rails then comes back and says, that's great, handle it like this. And that might be handle it by uploading to object storage or so on. Or it might be handle it by sticking it into a temporary file and telling me where that is. But Rails is still in charge of how it gets handled. Is that right?
Yeah, sure. But I think it's the only case where we are not proxying the request to Rails, but we are actually changing the URL and asking Rails what to do with this, and then doing something and inform Rails about the outcome.
Right. So there's some pre-processing on the request there. Okay, that's fine.
Great.
Did that answer your question, Daniel?
Yeah, I think so. I think the intent with some of these questions is to sort of, as I mentioned in the sort of introduction of the document, was to sort of figure out if a sort of version of a container registry would make sense to be implemented in Workhorse, and to what extent. And so I'm just trying to get a basic understanding of how Workhorse fits together. So that's kind of, I should have identified the intent in that question. Sorry about that. Yeah, I think next question was something like container registry. We're currently just using lightweight shims for a couple of endpoints. And I think we've got limited experience with that. We're all quite new. And we're still learning the code base and how everything fits together. I think what's happening right now is effectively just a proxy for the Rails API is just a proxy for the container registry service, which is an implementation of Docker distribution registry. And so I'm wondering if a service like that has been would sort of work in the sort of Rails/Workhorse model. And I feel like you've also answered that further down the document as well, where you were sort of saying, what was it? you were talking about that it was, basically just reverse proxying and sort of just handling Rails requests. Is this a model you think would be supported though? I mean, it seemed like with your link to the pages issue, you were sort of saying you thought it could be sort of moved into Workhorse. I'm just trying to understand how we should think about the design direction is really what I'm answering for.
These shims are essentially an example of Rails having the control over what happens, so it's absolutely fine. In the dependency proxy that was implemented a while ago, we ended up putting a lot into Rails, and some of it should have gone into Workhorse instead. So I think that we can follow that model certainly as possible, and we can do more in Workhorse than we did in that implementation. In particular, I think currently the dependency proxy does the actual proxying inside Puma. We only enable it when Puma's the application server we're using. And it's doing the thing that Workhorse would normally do, which is taking the bytes from the Docker distribution registry and streaming them to the eventual client. Normally, Unicorn or Puma would tell Workhorse to do that. And that would be a perfectly reasonable thing for Workhorse to do. In this case, we ended up writing it in Rails, partly because there was a lack of appreciation that it was meant to be in Workhorse. And then we kind of said, okay, how can we get this merged in time for the release? What can we do? We can't rewrite it all in Workhorse in 10 minutes. So we ended up merging it with a Puma-only guard because it's less expensive in Puma.
Interesting. So there's, and that's, I mean, dependency proxy is an interesting area of conversation as well, just for that exact reason. Thank you for that. That's really helpful. Okay. I think these questions I'm asking seem to be for sort of a similar vein. So I'm not sure there's a whole lot of value in sort of going over the next one because it's basically the same question angled a different way, and I don't want to waste everyone's time. If we, I'm going to skip that one. So if we implemented a replacement container registry in Rails using Workhorse for long running and high load endpoints, would this be a good pattern for Workhorse? Because it feels like as a reverse proxy, it sounds like you're saying that that would be viable, but I'm not, it sounded to me like we hadn't really done it at that level before as being like, hey, this is a Rails service, and then we just basically 60% of it is in Workhorse because that's what the load on this service demands, or whatever it is. I'm trying to figure out what do you think about that?
In terms of 60%, is that like 60% of the traffic or 60% of the implementation?
I'm just picking a number out of the air because I feel like we're going to end up, given the load that we're seeing on the container registry right now, which is pretty up there, I feel like we're going to end up having a lot of demand. It's going to need a lot of requests per second, a lot of long-running queries. So it's going to end up being a high-load application, and that will need to be in a high-performance area of the code base.
I think there are at least two things which, certainly from my perspective, are higher load and already have this pattern in Workhorse. The first is git clone over HTTP or git push over HTTP. That has the same pattern. You do the git clone or the git push on your client. That goes to Workhorse, which passes it to Rails. Rails replies with an authorization response to Workhorse saying, yes, this clone can go ahead, or no, it can't. If it's a yes, Workhorse then goes and talks to Gitly and sets up a communication channel between Gitly and the Git client to actually do the git clone or git push. And that is really high throughput. There's a lot of that going on. We also have a very similar pattern, and I'm trying to remember what I was going to say here because it is a similar pattern with something else, and I've forgotten what it is. Yeah. So there's something else.
Well, we also have artifacts. Pattern. We have artifacts from CIs. They are doing
exactly. Yeah, CI is exactly what I was thinking of. Yeah, so CI artifacts do this, and also CI jobs. Again, when a CI runner requests a job from GitLab, and what's actually happening there is most of that load is sat in the Workhorse and never reaches Rails. There's some very clever Redis caching going on in PubSub in order to efficiently distribute jobs that need to be run to runners waiting for jobs. That's got a lot of complexity in Workhorse, and it's been okay. You know, I was quite worried when we merged that, but it turned out to be fine. So I don't think complexity in Workhorse is necessarily a barrier. as long as the control logic is not in Workhorse. To me, that's the distinction that matters.
Right. And I think that a little bit your follow-up note here, Nick, the philosophy of Workhorse is dumb as possible. It should just do what Rails tells it in the main. So, yeah, I think we're, I'm trying to be respectful of the document. I don't want to go too off track. So if we're expecting things, this is your response again. If we're expecting things to happen in the background with the input from Rails, housekeeping runs say Workhorse isn't a great choice for that functionality. So that suggests to me that if we'd sort of decided to move forward in this direction, then we would need to sort of have an approach to architecture that supports that sort of basic premise of design, which is to say, you know, control gets handed off, and then there's long running, you know, housekeeping stuff in the background that gets, you know, as a separate service as well.
And if we take the example of garbage collection of old Docker images, which I think is one of the main things we've got our eye on here, the way that would work if Workhorse and Rails were involved in that, I think, would be Workhorse and Rails would be the fairly ordinary Docker registry together, but when it came time to clean up jobs that aren't anymore, so when it came time to delete images, Workhorse would have no part in that. Instead, there'd be probably a sidekick job or something running in Ruby, which would then do the deletion. Or it might be an API call out to a separate service, but there wouldn't be a case where a background job in Rails would ask Workhorse to do something. That would be, well, I mean, that would be possible in some respects, but it would be weird. I wouldn't expect that to happen very often.
Yeah, okay, that's a useful distinction. Thank you for that. And then, from limited understanding of current Docker registry, except it's very arm-length from Rails, what to operate independently as a shared secret. Yeah, the container registry is just a straight up implementation of Docker distribution registry. And there's a very light shimming as far as I know. I haven't done a heavy investigation of exactly what are in those shims. You know, the idea being that we're basically proxying API requests across to the native APIs for a Docker distribution registry. Yeah. So right now there's sort of an inflection point that we're planning for as far as our product design, even aside from the data storage problem, the garbage collection problem, which is fundamentally an issue of a file storage being used as our manifest store, which means that we can't delete stuff online because it's always open or whatever, right? So we have to turn it read-only or off. So, you know, first step is how do we get to a point where we can actually garbage collect online? And does that mean we redevelop a whole service? So just from a conceptual level, unfortunately, as I mentioned, the whole team's pretty new. So we're all kind of getting our head around a lot of this stuff still. So I apologize that I don't have really good, solid, really technical, low-level answers. But at a high level, those are the two drivers, as you mentioned, the data storage issue of garbage collection, and then the longer-term product goals where we don't really have the ability to like even order a list of images in a way that makes sense to our customers, which is obviously not great for our customers. It's not a good experience. And so moving forward from that, how do we integrate the data store into our product to allow our customers to have a better experience overall? So it sounds to me, sorry, I don't want to go off track again. Does that sort of answer the question you put down there, Nick? I don't want to.
Yeah, absolutely. I think that makes perfect sense. Yeah. I guess I am quite interested with the parallels of GitLab Pages, and that's where I'm coming to maybe on point 6. Yeah. We did have a very similar discussion between myself and Camille and Darby Frey and the Geo team around GitLab Pages, which has a similar problem of having a huge amount of data on disk, and it's just unwieldy to manage. And I did put forward a proposal to completely replace the GitLab Pages daemon, which is analogous to Docker distribution registry here, with endpoints in GitLab Rails served by GitLab Workhorse. And it was an interesting discussion, and in the end, I think we decided not to do that. We preferred to have our separate daemon doing the hard work that didn't need Rails to be involved at all. And so that's not necessarily the way I would do it, but it does kind of point us to where maybe we can go with this in terms of other people's opinions. I don't really get to say what happens about everything, unfortunately. So one thing that comes to mind is we have this Docker distribution registry and we can clone it. On the other hand, we can just pop a shim around every single endpoint it has and use that for reference counting and tracking what things are where. And that can be done in Rails, it can be done in Workhorse, it can be done without involving Rails at all, I think. And I think that would give us the data that we need in order to safely do garbage collection. And I suppose it would have to post to Rails when a new image is created in order to say, there's this new image that exists. But that could be an option to consider. I don't know if you've thought about that at all.
Yeah, one of our big drives is to get some instrumentation around what's being used, and that's really important for decision-making purposes. I mean, Tim could speak to that at length because we're all like, okay, how best do we instrument this code base to understand what our users are actually doing, what the load is at, and all that sort of stuff. And one of the things we kind of quickly run into there is where that effort goes in terms of delivering code. And so what we're doing is we're working in from, say, page requests on the side and various endpoints that we already have. When it starts getting into actual endpoints inside the Docker distribution registry, it starts feeling like, okay, we're going to be contributing, to a fork or the actual project itself. And it's just allocation of resources, given we've got a very small team that's just very new. So certainly had occurred to us to do that. I think some of the considerations we have about that type of effort is around the, not only let's figure out what we're actually using, but in terms of what are we actually doing with this product, and do we need this whole product to actually satisfy the needs of our customers? And so that's kind of another consideration in terms of effort. I really appreciate the example of pages that you mentioned, Nick. That's actually really interesting, and I kind of have a tendency to not go off in my own direction without figuring out what people have determined to be helpful in the past. So I've found that very helpful. Thank you very much. I don't know if that answers your question, but I think it's actually a really useful question to ask because that could be another path towards implementing our own, as I think you're implying. Which would be to say, hey, let's build shims, then we know what it is, and then we sort of chip away at those shims in terms of turning them into a full service. I think the shared data storage ends up often in object storage anyway. And so, you could end up actually implementing it similarly and sort of chip away at it that way, which it might be an interesting approach too.
At present, if we just focus on garbage collection, reference counting is what we need to achieve that. So the shim allows you to write that without changing any code in Docker distribution registry, without needing to fork it and without needing to continue to maintain it. And the question is just where it goes. That kind of thing could quite happily go in Workhorse, keeping its state in Redis or somewhere else, even in GitLab database.
Yeah, I think Camille's done a really good job of sort of documenting that thought process of how do we get to a point where we can reference count. And I think, as much as I believe that to be the actual core problem of why we have the issue with cleaning up the data, I'm actually not sure it's our critical path, just because we can't clean up, even if we wanted, even if we figured out the reference counting problem, we still can't delete any blobs anyway, because we can't shut down the service, right? Because at that outage level of being a week, 2 weeks of having in read only or offline, it's just not possible to do that for our customers. That's going to be a nightmare. So I think the idea that we had through all of these conversations was to think about it more like, okay, well, let's have a separate service that we can start migrating into. And then at some point we can just say, okay, we can automate that migration through push and pull and all that sort of stuff. And at some point we say this service is discontinued, and then you shut it down and the whole thing goes away. And then you don't have to deal with the reference counting problem on the file system and work out what's actually been, because it's reverse, right? Because we have to, it's a tough problem, and Camille's pointed out how difficult that would be to solve. But again, even if we did solve it, I believe we still have to shut it down to deal with the problem. So although I could be wrong there.
Yeah, I don't know if DDR will let you essentially force remove something. And I don't know if you can say to it, I have determined it's safe to remove this blob, so do it, and I'll take the consequences if I'm wrong. If it does allow that, then great. If it doesn't, then the shim is not too useful. So that's maybe something to look at.
Yeah, thank you. Yeah. And I think, yeah, that's a good question. And do you want to go into the last one, Nick? I don't want to speak for.
I kind of spoke a little bit to it a little earlier, which is even if we build our own, we still have the choice of whether to implement the functionality in Go or whether to implement it in Ruby. If we do it in Ruby, then the monolith is an actual first place to go. If we do it in Go, then it'll be fast. And that's kind of fast to run, not necessarily fast to write. And to me, that's a more interesting question than right at the top. There was this thing about, do we fork DDR or do we build our own solution? And from my point of view, if we build our own solution in Go, we're going to be pulling in a bunch of code from DDR anyway. If we build it in Ruby, we can't do that. We have to re-implement that code from scratch. So, and if we do it with some in Workhorse and some in Ruby, then Workhorse can pull in DDR code. So to me, that's the more interesting question. Is this code going to be Ruby? How much of it is going to be Ruby? I don't really feel the need to get hung up on, are we going to fork this existing code base or start writing code? Because at the end of the day, it's all copy and paste. Does that make any sense?
Yeah, it totally does. It's totally a question we've been thinking about. Alessio, did you want to?
I had kind of question on top of this question, and because I was partially involved into looking into this because I've been working with the storage problem for GitLab.com. So I'm kind of more biased toward how can we run this safely on GitLab.com. And the thing that I was looking at when I was investigating a bit is about the middleware that we can implement in Docker distribution itself. Because there are two injection points. One is the middleware, the other one is the webhook thing. So even if we fork Docker distribution registry and then we talk in Rails only through middleware, but I think it's still Go, or the webhooks, we can still retain a lot of control, but being kind of backward compatible, because I'm really scared that tomorrow Docker release registry version 3 with a new APIs, and everyone expect this to be ready before yesterday, and you have re-implemented everything in Rails and say, yeah, but we have another roadmap for this year, and we don't have engineering resources for implementing the new shiny thing. So this is something. And the other one is more about how do we think we can migrate this on GitLab.com? Because if we can't put this offline for garbage collection, we can't even put this offline for migrating to another thing. So, because this is the kind of solution that you start developing in a vacuum, and then you have, yay, I have a new implementation that is working. And then you need months for building a way to migrate information and making sure that once you enable it in production, you can still roll back, or having, let's say, some namespaces going to a new implementation and some namespaces still going to the old one. I mean, it's not just about developing this, it's developing this and allowing us to go back and forth between the old and new implementation.
Yeah, this is definitely something, I didn't mean to cut you off, Alessio, but that's definitely something we've been really considering. And I think it ties in well with the consideration around how we do garbage collection and the reference counting problem, and how we then clean up what's existing. And in some of the conversations we had, there's actually videos are online, and I've linked with them in some of our other documentation of conversations we have with other peeps, Grzegorz and Camille and DZ. We sort of thought through that problem, and to me, I think the simplest the simplest answer to that problem is that we don't deal with the old data and we suck up migrating everything over, so we can do a pull and a push to get the history of what's in the actual existing solution. And whether we fork it or not, it has to support push pull and all of that stuff anyway, right? And then at the point we sort of say, okay, after 6 months, you know, and this is just one idea, 6 months or a year, you go, okay, that service is going away. We drop the service and delete everything. It's gone. That's a pretty hard thing to ask our customers. I get that, but like trying to figure out how to solve the reference counting problem, how to shut everything down, how to actually have that support is really problematic because we just won't really know if the manifests are up to date. We got all the time offline calculating, doing reference counting is really like risky. And so doing that sort of in-place migration would allow us to say, okay, let's have a separate configuration for, we use this version of the registry, version 2 or whatever it is. These are the endpoints that point to the new service. We can do, like I said, automated push and pull at that point. I don't know if that addresses exactly what you're raising there, but it did sound like that's something we'd sort of talk through of like, okay, how do we handle that process? Is that so kind of...
Yeah, Jeb, let me ask a follow-up question. So the thing you're saying is that the problem we have is that there are blobs that are no longer referenced and we can't delete them because we can't do the reference count, put them offline, but we can online reference all the tags and images. So we can get those and push them to the new services in let's say background. And once it's done, and we shut off the old one and start using the new one. Okay, yeah. Kind of makes sense. I think this will take a lot of time. So keeping this in sync over time, because people, I mean, Auto the DevOps is an example. Auto DevOps keeps pushing stuff every commit. So keeping this working, yeah, it's kind of...
Well, and I think with Auto DevOps and the sort of automated processes that we use, it really, and I'm not sure I understand everything in every detail technically, but if we say, okay, we have a new service, we've tested it, it's ready to be used, you just change the configuration and everything in Auto DevOps goes into the new service, and that's the end of it. Like, you know what I'm saying?
You need something somewhere, and this is the right question, that can tell you this is ready to go to the new one, this is ready, still have to go to the old one. And in between, things may not be working as expected. So you need some emergency brake to go back to the old one. Because I mean, here we are dealing with user data, potential data loss, data corruption. So it's not something that you say, yeah, it worked on my laptop. I don't know why it's not working on GitLab.com.
Yeah, I mean, I think building a whole new service has definitely got a lot of considerations. I think the idea is having them both running at once is the safest option, because we can go to one and get the other one. If we try to do a migration, that we don't know whether manifests are up to date. Even if they are, we're using that anyway. Like, there's a lot of considerations, and I think we're pretty much out of time. So I don't know if we can get into it too deeply. I'd happily sit down and chat with you, Alessio, about it. I think it's something that we've been really working really hard to try and get a good understanding of. So the basic idea, as I mentioned, was to say, well, let's run up another service. Let's do a migration, and that could be manual or automated. And then once you've tested it and happy and it's working the way it should, do that migration, and then you can kill the old service after some timeline, right?
Yeah. The point is that migration is not instantaneous. It takes time. No. And at some extent, it's the same as doing putting it in read-only and doing the reference counting, because we don't know how long it would take in both cases. So during the migration window, we still have this unknown territory while we are moving stuff, and people cannot use it, maybe, or cannot push it, or we have to think about how can we deal with read and write operation during the migration phase.
Yeah, and I think the basic concept there was one of those services would always be writable during that migration. And so I would switch to the new service and I'd be able to write there. I wouldn't be able to write to the old service. So okay, after this point, you're on read access only to the old service. New service is read and write. So you can start using that, but there should be, right? So totally valid point.
Okay, yeah.
There was one more thing in there that I just wanted to pick up on, which is at the start when we were talking about injection points into DDR, and you mentioned webhooks versus middleware. I just wanted to make the point that we did used to use webhooks for geosynchronization, and they are not reliable at scale. I don't think we can rely on webhooks for reference counting. It's just not something that, in my experience, has gone well at all. So if we have a choice, anything but webhooks there.
Cool. All right, and we're definitely at time now. Thank you so much, everyone, for your time. And Alessio, I might try to catch up with you some other time to discuss some of these ideas. Thank you.
Yeah, sure.
Thank you, everyone.
Bye.
Bye, everyone.